Okay, so our next presentation is by Greg Peisley, behind the scenes of fire assay and lithium borate flux manufacture. So Greg's been involved with the manufacture and distribution of fire assay flux for over 30 years. He started a new company, AzoMin, 6 years ago, and has been supplying fire assay flux to all major lab groups throughout Australia. The business has grown to also include supply of equipment such as flux dispensers, tumblers, and has recently commenced manufacturing of lithium borate fluxes in various forms. Please welcome to the stage Greg, everybody.
All right, thanks very much. I like that photo. I had more hair back then. The wonders of AI. A peek behind the curtain of flux manufacture. I'm sort of between a rock and a hard place a little, because I'll be talking about not the application of fire assay flux. I leave that up to the laboratories. They're the experts in that. But how we make it to meet a particular standard. So there are some dark secrets there once you get behind the doors in the factory. I may not be able to give you all of those, but I'll do my very best to give you a snapshot of what goes on behind the scenes and how we finish up with our product. This is a global perspective. We supply flux to various labs around the world, and if it's made in various spots in the world, particularly North America or South America, it's made just a little differently. So what you get in one lab in the Americas may actually be slightly different to what you receive in a lab in Australia. But in the end, it doesn't make a hell of a lot of difference, because fortunately fire assay is a very robust technique, and some of the nuances that I'll talk about, they're there, but they don't really affect the outcome of a fire assay analysis. I want to have a bit of a walk through some of the manufacturing controls. Oops, how do we go forward? Okay, so we'll spread around the world, have a look at a few different things. The manufacturing controls, the future possibilities, some of the things that are happening in fire assay and the changes in the analysis, and also what it's not about. As I mentioned, it's not about how you perform a fire assay. It's about what goes on in the background. And I'm also acutely aware that I'm the only thing that stands between you and morning tea. So I'll be as brief as I can. And I'd also welcome any interaction. If you have a comment or a question as we go along, please feel free to jump in. Don't necessarily wait for question time. So some of the global variations, silver is a good place to start. Silver in Australia will be added as silver nitrate, highly soluble, and we solubilise it, we spray it onto a carrier, and that's then added into the flux mixture. I like that technique because you don't have any particle size variation issues. You get very good homogeneity. And the problem with adding silver is that you're trying to add 100 or 200 grams of product into tons of a flux. So it's easy to get it wrong and to get a hot spot or a no spot of silver. The solution process works well. If you were to go to North America and get your flux there, the silver is actually added dry, and they use insoluble silver sulfate. So it's an entirely different path to getting the product into the mix. I believe they mill it to get a consistent particle size, then mix it in a carrier, so it's a dry mix, and then add that into the flux mixture. Two different ways of getting there. They both finish up at the same point though once you are doing the analysis. I threw in dense soda ash there, although I could well have left it out. It's one of the products that makes up the bulk of fire assay flux. But it's one with very little variation from place to place around the world. The only real issue with the soda ash is that we want to get it into the factory in a free-flowing form. We don't want lumps, we want to be able to dispense it easily. Beyond that, no great difference. It's just a bulk product. The anhydrous borax is a little different. There are very few manufacturers of anhydrous borax around the world. Some comes out of North America, some comes out of Europe. It's been a moving target, that one, ever since COVID. When COVID hit, like all the industries, we had a hell of a time getting any product in from overseas, particularly soda ash because of the limited supply options. And then to make matters worse, one of the main plants in America that couldn't get product onto ships, once the ships started to become available and the shipping containers, they had a lightning strike on their plant, which took out a couple of transformers and set them back about 6 months. So tight supply became even harder, and it was really a hand-to-mouth existence on trying to get product flowing through the supply chain. And depending on where you take that out around the world, you'll get different particle sizes, which can be important because we'll talk a little in a moment about granular versus powder formulations. And when we get there, it's usually we're talking about litharge in the product, not the actual entire product, but borax does have some implications there as well. Flour is an important but small product that goes into the mix, and it's a carbon source. And like oils ain't oils, flours aren't flours. You can get various types of flour for applications in baking, and they can have different levels of carbon in them. So it's important to pick the right one so that you get the right amount of carbon present in the formulation. And silica is a bit of a problem child, because if you're going to manufacture a flux, you want to meet the specifications, which are typically less than 2 parts per billion gold. Because if you're looking for gold, you don't want it in the very thing you're applying in the analysis. And if you're going to get gold in a flux, it'll either come from litharge, which we'll get to in a moment, or silica. Quartz, they crush it, they produce the silica. If that quartz has some gold in it at the time, then it'll come through into the product. So all of the silica that we use is tested. We grab batch samples from every pallet of product that comes in, and we test it for gold to try and control that and make sure that we don't get any. On the whole, it's good. Over the last 5 or 6 years since starting the business, it's been interesting to watch what's happened, because it's been a little more haphazard with the quality of the silica than what I've been used to over years gone by. I don't know why, but it has. So testing of the silica is pretty important in the process. Now the big one is litharge, and I should have said that the manufacturer and supply of fire assay flux is an unusual thing in the way that it happens. Most companies develop a product, Datamine develop a product, they go to their customers and say, hey, we've got this and we believe it can solve this problem for you, and give it a go. Flux works in the exact opposite way. We don't make a flux and go to the customer and say, try this out, it will solve this problem. The customer says, this is the flux I want because it will work in our laboratory under our conditions with our ore samples and what have you. Can you make it for us? So it's the entire reverse. It's actually driven by the customer as to what they want, rather than us saying to the customer, this is what we believe you should have. A little bit odd, but that's the way it works. And with litharge, big global variations in litharge and the types of litharge that are available. The litharge, as I said, is a key carrier of gold if there's going to be an issue with gold. So we test that uphill and down dale to make sure that we don't get gold through the litharge in the process. Getting gold-free litharge isn't terribly easy. There are many litharge suppliers around the world, and they make it for batteries and PVC stabilizers and all sorts of other things. But when you speak to them about the product they supply and you say how much gold's in it, you'll get a blank stare come back, because they haven't got a clue. And they haven't got a clue because they've never needed to test for it before, because our application's quite unique. It's nothing like what they're used to in their industry. So getting supply of quality litharge is very difficult versus getting supply of any litharge. And in some parts of the world, one in particular, which has tariff protections on it, and I'm not talking about America now and Donald Trump, this is in South America, the litharge that the flux they make has anything like 6 to 10 to 20 ppb gold in it, versus the product that they would get from us or some of our competitors that would have typically about 1 ppb gold. And they do that because of the tariff protections in that country, and trying to get product into that country isn't easy. In fact, it's not possible because there's a local supplier. The local supplier has no competition, so they can put out any rubbish into the market, and that's what the market takes. Interesting situation. Now, with the litharge, until about 15 years ago, all of the litharge used to make flux was a powdered litharge. And then around 15 years ago, granular litharge was introduced, and that was driven by OH&S. Granular litharge isn't as dusty as powder litharge, so many of the labs jumped on that as a product to give better dust control and then lower lead content, blood leads and the like in their workers. And that worked really well. But one of the interesting things that came out of it was that granular litharge formulations, although it had exactly the same level of lead content on paper, gave about a 10 to 15% lower button weight when it was fired. And that was due to the physical nature of fire assay, where you want to get an intimate contact between the sample and the flux so that you get a good firing and all the metals get pulled down into the lead button. The granular litharge changed that physicality of the flux. So the labs were getting different numbers. Some labs, of course, didn't like that. They wanted the number that they were used to, which is fairly typical, but that's the way it was. And little by little, it's been accepted into the market. And now it's probably about a 50-50 split between granular and powder products. Within the litharge, mostly we talk about gold-free, so that the gold content of the litharge will be less than 2 ppb. But there is also gold and silver-free. And if you're doing fire assay in North America, you're probably using gold and silver-free litharge in the flux. So you've got gold at less than 2 ppb and silver at less than about 150 ppb. In what I consider normal litharge, which is just gold-free, the silver may be less than 150 ppb, or it may be more. Doesn't really matter, because the silver is an additive into the flux, and that's the way the labs want it. In North America, they tend to want to make a baseline which they call silver-free, and then silver addition on top of that is a known quantity for them. The quality control measures that we go through, I guess I'll give you a little example of something that did happen. Fortunately, not with AzoMin, so with another company. But anyway, where we had feedback from a customer that said, "Oh, we're using the flux and we're not getting any prills, so there's no silver coming through in the product." So naturally, you race back to all your manufacturing information. You look at the bills of materials, and on the bill it said, yes, silver was added at this amount, but the customer is saying we've got no prill. What's right? Was the silver added or wasn't it added? So that process of controlling the information in manufacturing is one that we've focused on fairly heavily, and we've created a process that for us works really well, and it's dead simple, but it is what it is. So it starts for us with the creation of a master file. Customer tells us what they want to make, we take that information, we store it in a file, check it uphill and down dale to make sure that the transfer of information has been correct, and that's for us the source of everything. Everything flows from there. From there we create our bills of materials, our BOMs, and on our manufacturing sheet that we issue for each batch, we'll have cross-checks of numbers. So the spreadsheet will run back to the master file, pick up the quantities off the master file, give us a number of what the total weight should be, and we'll compare that to what is written on the sheet. And if those numbers check, it's all good. And we also do a double check on the maths within the sheet so that we get the right quantities as we're supposed to get with the multiple from the master file. So if there's any I guess, errors in the maths, we pick it up fairly early. And one of the other things that sort of every time we talk about QA, QC and how we control this information, one of the stories that springs to mind is the story with NASA, which you've probably all heard, where they had a process in 1999. They built a Mars orbiter, fired it off to Mars, an incredibly complex process to build a rocket and orbiter and get it out into Mars. And they managed to hit Mars. They didn't manage to get into orbit. They crashed the orbiter into the planet. And then when they went back and went through their entire process looking for where the errors were, they found out that what had happened is one group of people were working in metric and another group of people were working in imperial. And it was that simple. Something as stupid as that caused them to have such a catastrophic failure in their process. So QA and QC become, for us, I guess we take a fairly simple approach. What we do is to confirm we've got the right amount of product in the manufacturing process, we actually take a photo of it. Nice and simple. So if we're weighing out 191 kilos or something, on our batch sheet it'll call for that amount of product. The operator will write that number alongside the amount that's needed. But they'll also then take a photo of the actual output from the scales with the information alongside the scales of what it is that is on the scales. And that process works really well for us. It's very, very simple. And we've done that from day one. So if we have a customer, Rob.
Sorry for the interruption. You mentioned any time.
Yeah,
you just intrigued me with what you're saying there about the build of materials and using the consistency of the systems. What about America? Because they still use their pounds and all that sort of stuff. If you're having to manufacture for somebody over there, they would obviously give you the build in their system, not metric. So how do you fix that?
What we do is we take the bill, and if it is in metric, we do if it is in imperial, we do a conversion into metric. But we also take it as percentage weights, so we know that soda ash is 54% of the mix, or whatever the case may be. And in those situations, we also go back to the person that supplied the information once we have drawn up a bill, and we say, right, from what you've told us, this is what we're going to make. These are the weights involved. Is that correct? And hopefully they check it. Doesn't always happen, but there you go. So yeah, we take our little photograph. We've got that on our files from day one. So if any customer picks any batch from the last 6 years of manufacture, we can go back to that batch number, pull up the photos that are stored in that file. And if they say we're getting a low prill, we can say, well, this is the amount of silver that was added. It's correct in terms of the bill of materials, the formulation. Are there any other issues that might be causing the problem? Works well, and it's a simple and positive check that we've got it right. Right, so from our photographic record, we mix our product, we return product into the mixer through our dispensing system to make sure that we flush out any channels where product might be hiding. Once we get a uniform mix of product, we pack it, typically into 1/2 ton or 1 ton bags, and we sample that product out of the flow into the bags, and our sampling is done at the same point, at the same time in every batch that we make, wherever possible. So we'll take a sample from the flow of material. We have a retained sample which we keep on site until such time as we know that product will have been used up by the lab and is gone. So we keep it for 4, 5, 6 months. And we have our second sample that we send off to a third-party lab, and that lab will test button weight, prill weight, and gold content. And we do that for every single batch, and we record that information against the batch number as well. So likewise, if a lab says we're finding some gold, we can go back and say, well, this was our result. We also have a retained sample. How about we send that sample off to an agreed lab so we can get a third-party analysis or a fourth-party analysis to see where that stands. Right, and beyond our own sampling, what we also do from time to time is a round robin with the labs, where we'll take one sample of product, split it into multiple groups, send that off to a couple of labs, get them to fire it, give us the numbers back, and then we'll make those comparisons between the labs, which is always interesting because they don't always come back the same. But fortunately, the variations are relatively small. And we've found that mostly it's pretty good. The labs get it right, which is great. That's what's supposed to happen. Now, despite all those nuances and variations that happen in the background that never really see the light of day as far as the market's concerned, fire assay is a long-standing and a very robust technique. It's one that can handle those nuances that may occur and aren't going to give you variations in the results that the lab gets back. So while there's a fair bit that does go on in the background, it doesn't really cause us any grief as far as the lab's concerned. And fire assay is a very well-known, long-standing and well-understood process. And it's one of the oldest processes going around in the laboratories, and it dates back about 3,000 years. And I've not seen them, but apparently there are cupels sitting in museums over in the Middle East somewhere, which have been found from Phoenician times or earlier, where they've used borax to clean up gold, which is really the start of the fire assay process. So it's a very old technique, and in fact it's not until quite recently that a disruptive technology, I think it's a disruptive technology, has come into the market with the photon assay technique. Works well. It's typically used at higher levels of gold content on the samples, so things like grade control. Doesn't work well at the lower end where it's exploration. So we're finishing up with a market that's a little bit split between photon assay and fire assay, and there's a spot for both. And that's taken 3,000 years to emerge, so it's done pretty well over that time. Now, everybody wants to get lean, mean and green, and fire assay is no different. It's well known in the literature that things like tin and bismuth have been used as the collectors in fire assay rather than lead. People would like to get away from lead, but lead works, and it's done at the right price. But what's happened is in the last couple of years, one lab in particular has done a lot of work on the use of bismuth as the collector, and that's gathering some momentum. And that lab is offering a service now where you can choose to have fire assay done with bismuth-based flux rather than lead-based flux. And they've also done some work on multiple element analysis, so it's not just for gold. They're extending that to silver and some other elements as well. So not so much an ad for them, but just a comment that fire assay is changing like everything else to try and get greener and keep up with the times, and that process is happening right now in the background. Now, a little bit of an ad, I guess, for us. We get involved also in flux dispensing. We manufacture a volumetric dispenser, and the way it works is that we have a hopper. We have a hopper, bulk bag goes over the top, flux is dispensed into the hopper, and there's a series of cones under the hopper, so you get a set volume drop down into the tray of crucibles. Crucibles move backwards and forwards until they're all filled up, then they go off to the tumbler and then into the oven, and away they go. So there's been a bit of a change with flux dispensing. I mean, that process has been in the labs for some time by various forms. It used to be that someone would be reaching into an open head 200 kilo drum of flux with an ice cream scoop, scrape it up the side, drop that into the pot, and they were very good at it. They would get reproducible numbers, and they were very quick at it too. But the problem being, of course, they were contacting the flux and finishing up with high blood leads, which is not really what's wanted. So automation's the way to go if you want to improve those blood lead numbers and get things done a bit quicker and safer. There you go, picture of the pod array about to go into the machine and the bag sitting over the top of the hopper. Just to give you an idea of what it's all about. Right, now the other thing finally that we have just gotten involved in is lithium borate fluxes. So you would probably know it more as X-ray fluorescence analysis, and it couldn't be any more different to making fire assay flux. With fire assay flux, we make it and sell it in tonnes and container quantities, big numbers. X-ray flux is sold in kilograms, an entirely different animal. PPB, low detection limits are the requirement in an X-ray flux. And in fact, it's almost across the board, A to Z of the elements PPB, whereas with fire assay flux, we're interested in really only 2 or 3 different elements. If there was iron or something like that in the background, it probably wouldn't make any difference whatsoever. So a very different animal. It's made on platinum, which makes it difficult. The raw materials are melted into a platinum crucible, poured out as a glass. The glass is crushed and processed into a particular particle size. And in that process, we've got to control any contamination that may be picked up along the way. But interesting process. It's one that we've been involved in now for 6 months or so. So not a long time, but we see it as part of the growth of our business in the years to come.
Great, thanks, Greg. Thank you.